Hey guys, in my last two videos, I talked about named reaction under sigmatropic reactions. In those videos, we talked about benzene benzodiene rearrangement, Fischer-Indole synthesis, Somblet-Hausser rearrangement, and Claisen rearrangement. In this video, we'll talk in detail about Cope rearrangement. So, what is Cope rearrangement? A rearrangement of one fired ion in thermal condition is known as Cope rearrangement. A rearrangement of one fired ion molecule in thermal condition is known as Cope rearrangement. So the basic condition required here is thermal condition, and the molecule required here is what? One fired ion. So one fired ion under thermal condition undergo Cope rearrangement. This will be shifted here, this will be shifted over here, and this forms the new sigma bond. We'll get this product, will get here. Remember, when the product and reactant are same, you please observe very careful here. The reactant and product are same here. Only just rearrangement of five bonds is happened here. So this kind of Cope rearrangement is called as what? Degenerative Cope rearrangement. Degenerative Cope rearrangement. The reactant and product are both same here. So because of that thing, this is called as what? Degenerative Cope rearrangement. We'll see the second example. One fired ion is there. Under thermal condition, this pi bond will be shifted here, this sigma bond will be broken, this pi bond will be utilized for the formation of new sigma bond. So you will get this product, will get here, and you know that this will undergo tautomerization, and it gives you aldehyde. It will go, you know that this will be shifted over here, and this will be represented here as a negative charge, and this negative charge will react to this H plus ion, and you will get this product, will get here. We'll see the third example. One pired ion is there, and you know that you need a thermal condition. The change here is, instead of carbon, there is a nitrogen here. If nitrogen is present, the Cope rearrangement is called as Cope rearrangement. So here, this pi system will be shifted over here. This will be shifted over here. This will be used for the formation of sigma bond. So this will be the product. We forgot to mention the naming here. Look at here, this sigma bond is broken. We should name this as a 1-1. This is 2, this is 2, this is 3, this is 3. So it is 3-3 sigmatropic rearrangement. Look at here, here also the bond is broken. We should start numbering from here: 1-1, 2-2, 3 and 3. So it is also 3-3 sigmatropic rearrangement. Here also the bond is broken here, so we should start numbering from here: 1-1, 2-2 and 3-3. So what it is? 3-3 sigmatropic rearrangement reaction. In the fourth example, instead of carbon, we got oxygen here. So this is called as what? Oxycope rearrangement. So thermal condition is required here. So instead of carbon, oxygen is present. Because of that, it is called as what? Oxycope rearrangement. Next, this pi bond will be shifted over here. This bond will be shifted over here, and this is used for the formation of new sigma bond. This is your product. Fifth example, we'll see. What will happen here is, this is 1.9. You have to identify 1.9. This is 1, this is 2, this is 3, this is 4, and this is 5. At 1, 5 position, diene is there. So this undergoes co-rearrangement. This pi bond will be shifted over here. This will be shifted over here. And this is used for the new sigma bond. I'll write the product here. Here now we need to check which membered ring will be formed here. Look at here, 1, 2, 3, 4, 5, 6, 7, 8. So 8 membered ring will be formed here. We have to write that very carefully, or else the confusion will be created here. So 8 membered ring I have to write over this 6 membered ring. Look, this is 1, 2, 3, 4, 5. We already wrote 5 here. Next I will write 6th carbon, 7th carbon, and this will be 8th carbon. And here, here it is a double bond, and here it is what? OH is there. Next thing you know that tautomerization will be there. This will be shifted over here, and this will be represented over here, and finally we'll get this product. Get here. We'll name here. This sigma bond is broken here. So 1, 1. This is 2. This is 2. This is 3 here. This is 3 here. So it is 3, 3 Sigmatropic reaction. My advice in this example is, it is a bit confusing while writing. So systematically you number how what membered ring, new ringer, what new membered ring will be formed. You systematically analyze that and then write. Simply, if you are not thinking about the new formed ring, you will be get confused and you will never solve the question. So my advice is, just have a look over that. What will be the new membered ring? We'll see the 6th example here. Again, you check whether it is 1.9 or what. We'll name here 1, 2, 3, 4, 5. Yes, it is a 1.9. It undergoes co-rearrangement under thermal condition. This sigma bond will be broken. This will be shifted here to form a new sigma bond. Again, here my advice is, you write the structure as it is so that you will not be confused. Look here, I will write as it is. I will write. So earlier this was here, I will write that. This was here, this was here. The new bond is formed between these two things, and phi bond is shifted over here, and this is one more phi bond. So this is our product here. We must name this one. This bond is broken, so here it is 1, 1. This is second, this is second, this is third, this is third. So it is 3, 3 Sigmatropic rearrangement. We'll see the 7th example. We'll see here. This is a pretty simple example, but the challenge present over here is stereochemistry. Earlier, no stereochemistry was not present in the previous example. Here, the challenge is stereochemistry. thermal condition 1,5-diene is there. So what will happen? This will be shifted over here. So it looks like product is this. But the challenge here is whether I have to write these methyl groups outside or inside. Here in methyl group, this methyl group, whether should I write inside cis or trans? That is a challenge for me here. So how to solve that? Here comes stereochemistry will help us here. You know that we have to write, JRF we have to write for this one. There are 6 carbon atom here. Both are trans here. Sorry, both the methyl groups are in a cis position. In 1,2 position, cis positions are there. From our knowledge of stereochemistry, at 1,2 position, both are axial or both are equatorial, means what? These will be in a trans position. At 1,2 system, at 1,2 position, if one is axial and another one is equatorial, or if one is equatorial and another one is axial, means this will be what? Cis. So in this case it is a cis. What I need to do is, one I have to put axial and another one I have to put what? Equatorial. So first one I'll keep this as a axial and another one equatorial I'll keep, and then we'll do the rearrangement reaction. This will be shifted over here, this will be shifted over here, and this will be used for the formation of new sigma 1. So what you will get here is these will get. See, this methyl group is above, we can write like this. This methyl group is above, you can write like this. So the product you will get here is, look at here, it is a cis and this is trans. So one is cis and another one is trans. Methyl group, here I have to write cis and here I have to write what? Trans. This is the methyl group and this is the methyl group. So this is the answer. For the people who don't know what is axial and what is equatorial, I will quickly explain. If you are writing above here, this is axial, and if you are writing here, this is equatorial. This is axial and this is equatorial. This is axial and this is equatorial. This is axial and this is equatorial. This we'll study in detail in our stereochemistry lecture. For time being, you understand this. We'll see the 8th example. Here also the challenge is stereochemistry. We'll take a chair conformation. Here both are trans. So we'll write a trans here. Look at here. This is a trans. Here also trans is there. We'll write like this. Look at here. At 1,2 position, it is a trans. At 1,2 position, it is trans. At 1,2 position, trans means what you have to do? You have to place either axial or equatorial. We'll place equatorial. Means this is equatorial and this is equatorial. Both the CS3 groups, we are placing equatorial. This means it is a trans. So next thing, there will be a transfer of this pi bond will be there. This will be shifted over here and this will be used for the formation of new sigma bond. Next, what will happen? We'll write this trans only. We'll write here. We'll write trans only will write here. Here we'll write this as it is. Here the new pi bonds are formed. So this is below and this is above. So both are trans here. Look at here, both are trans. So this will be equivalent to, you know that both are equatorial means you know that it is at 1 2 position, both are equatorial means it is trans. One is CS3 below here, one is what CS3 above means it is a, so this is a trans, and these are, you know, this is trans, so I'll write above, and this is also trans, so I will write like this. This is the answer here. We'll see the 9th example. Again we have to write the chair form, we have to write for this one. The first one here is trans and the second one is cis, and here it is trans means I have to write both equatorial, you know that thing, equatorial or axial means it is trans, you know this thing. Next the pi bond will be shifted over here, the sigma bond will be broken and that will form as a pi bond here, and this will be used for the formation of new sigma bond. So this will be remain same here, and this is our product, right? So this is equivalent to, you know that in this position one is, this is equatorial and this is axial, one is equatorial and one is axial means you know that it is a cis. And here look at this, this is a trans. Here look at this, this is also a trans. So this is the answer. We'll see one more example like this, 10th example. Directly we have to write said from this one. This methyl groups are trans means you know that both you have to write equatorial or equatorial axial. I am writing equatorial. You may write axial also. Here we'll write a double bond, we'll write here, and in this case both are a cis. I have to write, to make it cis I have to write like this. So next what will happen, this pi bond will be shifted here, this will be shifted over here, this will be used for the formation of new sigma bond. Next this is also axial, this is also axial, and here phi 1 like this I have to write, and this I have to write like this. This is equivalent to both are axial means it is what, trans. I'll explain you one more time. In 1 2 position both are equatorial or axial means it is trans. In 1 2 position one is axial and another one is equatorial, or one is equatorial and another one is axial means this combination gives what, cis. In this case both are axial here, so it is a trans, and here you have to write double bond, you have to write, and this one it is trans, I'll write trans, this one also it is trans, I'll write trans. So this is the answer. Thank you for watching.